Welcome to lesson 3 in this series. As usual, pause the video, have a go at the question in your own time. Okay, the answer to this first question is x equals 27. I'm now going to show you how to do it. Remember, you can skip explanations as you want to. I'm going to times both sides by 11. So it gives me 11 times, and I'm messing this up, 11 times this is 11 times this. Oh look, they cancel. Now I'm going to minus plus 5 from both sides, because I want to do I'm trying to plan it out so it'll work. They cancel. X equals 27. Boom. There we go. Let's do the next question. Pause the video, have a go in your own time. My answer to this is b equals 0 and or c equals 0. That is my answer. You might have said not possible. Well, I'm going to say you kind of get points for that as well, but we can quite clearly state something, which is that either B or C has to be 0, which seems like a fairly concrete answer. It's got to be worth noting. Next one. Have a go in your own time. I'm going to say not possible. But you might have done this. You might have said, I'll minus c from both sides. And I'll end up with b plus c minus c equals minus c. They cancel, so b equals minus c. I mean, all you've done is rearrange it. But at least it's saying what b is in terms of c. Which you could say is the answer. Yeah, you know. Maybe this is why they don't have not possible questions in exams, because it starts becoming a bit too philosophical. I still think it's useful for learning. And we'll definitely see later on how it can become very useful to have not. Right, pause the video, have a go in your own time. And the answer is x equals 0. How do I know it? Well, one reason is because x times something is 0. Obviously that is 0. Well, you might have divided both sides by 11. I'm never super keen on doing that because I kind of feel like you can do it by inspection. But horses for courses. Right, next question. Have a go in your own time. And my answer is I square root both sides and I end up with x equals 0. Now I realised that earlier I said I was okay with not dividing by 11. Okay, well you can also definitely just say, well, by inspection, being short for inspection. Inspection is when you look at something. You could just say, well, by inspection, x is 0, obviously. Okay. Or you might say, well, x squared means something times something is 0. Oh, well, that something has to be 0. Let's do the next question. The next question has 3 equations, so don't pause the video yet until I've written all 3 equations down. There we go. Go for it. And first of all, I'm just going to write out the answers, because that way you can see whether you got it right. A is 10, B is 10, C is minus 20. Having done that, I'm now going to do my answer, which is, let's start with this equation here. I'm going to add 2 to both sides, which means I end up with A equals 10. Well, I now know what A is. If I combine it with this equation here, then I can say that 10 minus B equals 0. I could just say, well, obviously B is 10, or I might add B to both sides and end up with 10 equals B. There we go. I always prefer to rearrange it to say B equals 10. Then we can finish off by saying, oh, we can now work out C, because we can take this equation. We know what B is, we know what A is. So we can say 10 plus 10 plus C equals 0. So 20 plus C equals 0, minus 20 from both sides, C equals minus 20. There we go. Let's do the next question. Pause the video, take your time. See you back here in a minute. Okay, so my answer is to say, oh, there's an E. I don't know what that means. Well, I do actually, but I'm going to pretend I don't. I don't know what that means. But it doesn't matter, because I can do by inspection. I'm going to write out the whole word by inspection just this once. Try not to be lazy. I can say by inspection, these top two must be the same thing. So 5x plus 1 is obviously equal to 2, because otherwise, because remember that an equal sign, the things on each side of an equal sign have to be the same. So now I can minus 1 from both sides, 5x equals 1. Then I can divide both sides by 5, x equals 1/5. Ta-da! The next question is a plot question. So let's plot these points. I'm going to be writing 4 points and then I'm going to write a question underneath, so maybe pause after you've seen the question. The question is, what is the rule? That says rule, R-U-L-E. My writing's a bit scruffy. Okay, welcome back. I'm going to draw a graph. I'm going to be quite lazy again. I'm not going to, well, let's do it. By the way, the rule is y equals 3. So if you're kind of happy, maybe you're going to move on. Maybe you want to watch me do it. 2, 3, 4, 5. Then we've got the minus numbers as well. -1, -2, blah, 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 blah. -1, blah, 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 blah. Let's plot the points. This one, we'll do it in red. X is 0, because remember x, comma y, because it's in alphabetical order, y is 3, so it goes there. Let's do the next one in purple. X is -2, y is again 3. Let's do the next two in black, because I'm running out of colours. 5, 3, and 1, 3. Oh, look. They're all on a straight line. And that straight line, how can we describe that straight line? How can we describe that pattern? How can we describe that rule? We could describe it as being y equals 3. There is a little bonus lesson with some more on this topic if you want to look at it. And remember, I don't always remember to say when there's a bonus lesson. So always have a look anyway to see if there's something that you think might be interesting. This is an expand question. Pause the video. Join me again afterwards. And the answers are, let's change colour, 6x plus 6y, 7x plus 7y plus 7. Why is that? Because remember, there's an imaginary times sign. Remember, the times symbol is the one that has an invisibility cloak. So if you can't see a symbol, it means someone forgot to write it, or it means that it's a times. And the times is next to a bracket, so it's timesing everything in the bracket. And that's how we ended up with those answers. And got a calculate question next. I'm going to write out some calculates. I'll let you know when I've written them all down. You can obviously get started straight away, but obviously pause it once I've written them all down. There's a variety here. Try a few different ones, see what you think. That was supposed to be a 4. That's the lot. Pause the video and then join me again when you've finished. Okay, so that's 4 times 4, which is 16. This one's interesting. They're plus and minuses, so we can just do them all at the same time. 5 plus 3 makes 8, minus 5 makes 3, plus 3 makes 6. Careful that you didn't do some cancelling that you weren't supposed to do. The cancelling you could have done there was the 5 and the 5. You couldn't cancel anything else. That's minus 1 times minus 1, which is 1. 1 plus 1 is 2, 1 minus 1 is 0. This one's interesting. Can you ignore the brackets? You can, because it's just around a single number. And then you've just got to realise that, well, that basically means 1 minus 1, which is 0. This is bidmass, 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 or you might have a different mnemonic for it. So we've got to do multiplication first. So that's 3 plus 8, which is 11. This one, you do indices before timesing. So 3 plus 4 is 7, so it's 7 times 2, which is 14. Let's do the next question. Oops. This is another calculate question. And my question is, if this is really easy, I just want you to think about why I've mentioned earlier that this is useful, if I have. That's all of them, by the way. And yeah, just think of this as learning. I use these patterns to learn very advanced maths as well, but I'm just using it just to learn the simple basics of sums at the moment. 3 times 1 is 3. 2 times 1 is 2. 1, 0, minus 1, minus 2. Why for me is this pattern useful? Because it's a confirmation that 1 times 1 is 1. Some students, I think, rightly say, well, everyone's so sure that 1 times 1 is 1. How can we be sure about this? Well, because we use patterns like this to justify how we think about maths, how we use maths terminology to describe things. Let's do another calculate. I quite like this one. Have a go in your own time. Join me back when you're ready. Okay, 0 plus 5 is just 0. Whoa, it's just 5, because you're just adding them together. The 0 doesn't have any effect. Does the 0 have any effect in the next question? It does, because you're timesing. In this case, if you don't have any 5s, you haven't got anything. In this case, this is very interesting. Because of the minus sign, the 0 doesn't really have any effect again. It's still just minus 5. But you can think about it other ways as well. This one, I prefer to turn it into a fraction. I'll then say, oh, well, that's just 0. Remember, a way to talk about that is to say, what is nothing shared between 5 people? Well, everyone gets nothing. Calculate 0.5. This is important for learning the fundamentals of fractions, that kind of thing. Here are my answers. That's like saying a half plus a half, which is 1. This is, I'm going to say it out loud, because some people will have got this wrong. 1/3 plus 1/3. What's 1 elephant plus 1 elephant? 2 elephants. What's 1/3 plus 1/3? 2/3. So that's the underlying reason why that works. Now let's finish, well, penultimate question. Same to both sides. Because I do like doing these questions. I think these are good practice. And I know that quite a few of you likely are finding this difficult. Okay, this is a weird question, but I hope it helps. You can probably guess what all 4 questions will be, because there's kind of a pattern to how I ask this. Obviously you can get started straight away as I'm writing this out. Pause the video, join me back when you're ready. Right, the first one is just a plus b plus c minus x, p plus q plus r minus x. The second one is just a plus b plus c plus x, p plus q plus r plus x. The next one, because plus and minus you do it once to each side. With divide and times you do it once to each thing. So that's going to be a divided by x plus b divided by x plus c divided by x equals p divided by x plus q divided by x plus r divided by x. I'm going to briefly look at this again in a second because you might have a question about that. Because you might have done it differently. The final one is ax plus bx plus cx equals px plus qx plus rx, because we've times each thing by x. Can we just, oh, can you, I don't know quite what happened there. Now, I just want to look here. You might have said this. Which do I think is better? I think this one is the better of the two. I think I'd rather see that just in terms of learning progression. But I mean, there's nothing wrong with doing it like this. And actually, if you've got a fraction with lots of things on the top and one thing on the bottom, you can split it out. So it's the same thing, written differently. But I think it's so fundamentally important to be learning that when you divide both sides of an equation, you simply divide each object. For me, in terms of how I teach, I think it's better just to do them separately straight away. That's my closing thought there. You know, that's not like a global rule for every time in life you see that situation, that's the right thing to do. But generally speaking, I think that's the best way to think about it. The next question, write as one fraction. Pause the video if you need to. The answer is that, because what is 1/3 plus 1/3? It's 2/3. By the way, this is the end of the video. There's no more questions. I'm just going to waffle on about these fractions for a minute because I know that some people are going to be finding the fractions a bit awkward at the moment. What is 1 elephant plus 1 elephant? 2 elephants. What is 1 pencil plus 1 pencil? 2 pencils. What is 1 blubbler plus 1 blubbler? 2 blubblers. What is 1/3 plus 1/3? Maybe if I write it with words it'll be clearer. That's 2/3. There we go. That's the way to think about it. See you in the next video.